Problem 12 is a nice mixture problem that I wanted you to set up with two variables and two equations. And so it says a chemist has one solution that's 10% salt and one solution that's 3% salt. How many quarts of each do they have to mix together to produce 60 quarts of a 7% salt solution? So if you got a weak solution of 3 and a strong solution of 10, when you mix them, your average is going to be somewhere between 3 and 10, and I want this one to end up being 7. So how do we set that up as an equation? I kind of talked about thinking about it in these boxes. I've got one container of X quarts of 10% solution, and I add Y quarts of 3% solution. I end up with 60 quarts of 7% solution. So I get two equations out of that. One is X quarts plus Y quarts equals 60 quarts. That's the first equation, the purple equation. And then I have the blue equation, which is 10% of the X quarts, which is acid, plus 3% of the Y quarts, which is acid, equals 7% of the 60 quarts that I want to finish with. And if you want, I could do this green equation thinking about it as 10%. So 0.10x plus 0.03y plus 0.07 times 60. But the blue and green equations are equivalent. I could just multiply the green equation by 100 to get the blue equation. And I don't have to worry about all those decimals if I want to. So either way, I can set that up. When I've got 10%, I can write it as 10, or I can write it as 0.10. I just need to be consistent because those equations are equivalent. So I'm going to use the blue and the purple. That's easier. And how do you solve that? Well, you could do it by elimination, or you can do it by substitution. In this case, I'm going to take that top equation and solve for y. Y equals 60 minus x, and I substitute that into the y in the second equation. I get 10x plus 180 minus 3x equals 420. 10x minus 3x is my 7x. And minus or equals 420 minus 180, and I can solve, and x is 34.28. So once I get one value of x, that's my 10% solution. I can plug it into the other equation to go back and find my value for the other variable, y, which in this case is 25.72 quarts.